Hi folks, this is the last of the linear systems videos. These types of questions can seem very confusing when you first look at them, and when you lay them out with the techniques that we're going to do here, it's totally possible to do them, but it sure helps to see how to do them first. If you're looking at them at the beginning, boy, they look really complicated and a lot of people just tune out. But let's do this together and we'll see if we can get through these kinds of questions. Sometimes you will get questions with percents and mixtures. Sometimes you will get questions based on money, which is a whole nother video I have. Sometimes they have to do with distance and time. And those are each their own video because they each have their own ways of solving. And that's why I didn't just put them all in one video, or it would have taken over an hour to show all those ways. So we're just going to focus on percent and mixture problems here. So we have Mr. Lee. He needs to make, and he must be a scientist because he's working with acid. And it's not something I would work with in my kitchen. I don't want to burn the skin off my hands, for example. So sulfuric acid is quite dangerous. Anyway, Mr. Lee, oops, and I just drew on there. Mr. Lee needs to make 10 liters of 42% sulfuric acid. 42%, that means if there's 10 liters of that liquid, that means 42% of it inside is sulfuric acid, pure sulfuric acid. The rest of it would probably be water, I imagine. Anyway, the acid solutions available, so Mr. Lee has he wants to make 42% sulfuric acid. The only problem is he has one bottle of 30% sulfuric acid and another that contains 50% sulfuric acid by volume. How many liters of each solution of each of these two have to be mixed together to make 42%? Do you see what I mean by a little complicated? Well, I would call them a little complicated too. So let's think about this. First of all, let's think about the amounts. First of all, we're going to take the amount of acid in one of them plus the other one. So we're going to say one is, here's the first solution. We'll call this the A1 could be the 30% solution, and A2 would be the 50% solution, and that will give us a total of 10 liters, okay? So these two solutions put together will make 10 liters. Now to do a linear system, we need to usually we have two lines, one above the other. So I'm going to write out another line. This time we're not going to focus on the volume overall. We're going to focus on just how much acid is in each one. Okay, now what that would mean is from the first solution, it's going to be 30% sulfuric acid. Remember, 30% could be written as a decimal, like this. So 30% of A1, and you could put 0.30 if that makes it easier for you to see or understand, but that 0 wasn't really necessary. So I'm just writing 0.3 A1 plus, the next one is 50% sulfuric acid, so 0.5. Instead of 0.50, I'm just putting 0.5 A2. So 50% of that acid is going to equal how much acid? Now it's not 10 liters. This is not 10 liters of pure acid. We want 42% solution of the 10 liters. So 42% of the 10 liters here. So really what you're wanting to find out is 42% is 0.42, but you multiply that by 10 liters, and we're actually looking, if you multiply those two, you end up with 4.2. That's the actual amount of acid that will be in this 10 liters. So that's where these questions get a little tricky, is that step right there. Okay? I'm just going to get the right pen here. Okay, so we have these two written out now. And what you do is put a line there. We want to get rid of one of these variables, either A1 or A2. It doesn't really matter. I've been using a red pen in all of the other videos I've been doing, if you've been watching those. And please do, because they do get easier as you do them. I'm going to get rid of this A1 here, term. So I'm going to multiply the top, every single one of these terms on top, by the opposite of this number. Instead of 0.3, I'm going to multiply this by negative 0.3. I'm going to multiply this one by negative 0.3, and I'm going to multiply the 10 by negative 0.3. By the way, that would give us negative 3. I'm multiplying them together, you would get negative 3. Now, these two here are going to cancel because they are opposite each other. These two, well, 0.5 minus 0.3 would give us 0.2. And I'll put that in green pen of the second solution. 4.2 minus 3 is 1.2. And the last step is we want to get A2 all by itself, so just divide 1.2 divided by 0.2 right here, which is something you do in algebra. And if you do that, 1.2 divided by should get 6. That means, so that's a nice whole number right there. That means that we have 6 liters of this solution. How many liters do we need of the first solution to make 10 liters? Well, that's nice. That's just, we know that 6 plus 4 would make 10. So we now know how much solution we need of each one. Okay? By how many liters of each solution must be mixed? Okay, well we have the answer. We need 4 liters of the first solution, and we need 6 liters of the second solution in order to make the 42% mixture that we're looking for. Now, if it was a test, you can check your answers. All you have to do is put these A1 and A2, put the 4 and the 6 in the second equation and see if you get the answer 4.2. So 4 times 0.3 would be 1.2. And 6 times 0.5 is 3. 1.2 plus 3 is 4.2, and that is the answer that was shown right here that we were looking for. And that way on a test you can say you know what's going on. Now your teacher is probably going to ask you in this class to give a therefore statement. So therefore it would take 4 liters of solution, the 30% solution, and 6 liters of the 50% solution to make 10 liters of the 42% solution. Because my writing is not very neat, I'm just verbally saying that out loud. Let's do I don't know, 1 or 2 more questions. This one is also, believe it or not, it's like a mixture question, but it's dealing with percents. In this case, it's about money. Okay? So Alex, it's about Alex. He had $10,000 to invest. Very nice. He invested part of it in a term deposit paying 4% per year, and the remainder in bonds paying 5% per year. If the total interest earned at the end of 1 year was $440, how much did he invest at each rate? Okay, let's break this up because this is confusing otherwise. It looks like there's 2 parts to this investment. Don't you see it? He invested part of it here and the other part here at 5%. So he had 2 investments. Investment 1 plus investment 2. I'm going to call the investments I1 and I2. And those 2 investments together totaled $10,000. Wow. Lots of money. So those are the 2 investments. Now, that is the total amount of money. Here we're going to talk, on this next line, we're going to talk about the interest. Okay? So it paid 4% interest of this investment. So I'm going to change the color here. 0.04 times the first investment. That would give us the interest for the first investment. For the second investment, it's 5% per year. So 0.05 multiplied by the second investment, okay, is how much interest altogether? It says at the end of 1 year, the interest was $440. So it's a system of equations, and we have a top line and a second line, and we really need just to cancel one of these out. I think the quickest way is to multiply the whole top by, I'm going to say negative 0.04. You can multiply each one of these by negative 0.04. So let's do that. really quickly. So that would be negative 0.04. Over here would be negative 0.04. And if we multiplied 10,000 times negative 0.04, well, 1, 2, 3, 4. That's 4 jumps over 1, 2, 3, 4. That'd be negative 400. That's what we would end up getting. Okay? So if we put these together, top and bottom, we would end up seeing that these two cancel. And over here we have 0.05 minus 0.04. That leaves us with 0.01 of investment 2. 440 minus 400 leaves us with 40. Divide both sides by 0.01 so that we find out that the second investment was, if you take this divided by 0.01, you get 4,000. So we know the second investment was $4,000. Now it's pretty easy to figure out the first investment because these two investments, if you look at the blue writing here behind these lines, investment 1 plus investment 2 was $10,000. That means the $4,000 plus this number here should equal $10,000. Well, $4,000 plus $6,000 is $10,000. Is that what the question was asking? If the total interest earned was $440, how much did he invest at each rate? We have solved the question. He invested $4,000 at 5%, and he invested $6,000 at 4%. And that's the kind of thing you would write as a sentence answer in this question. Okay? Just to save some time, I'm not going to put these numbers into the second equation here just to check and see if we get 440, because this video is just going to get too long. I'm going to do one more question with you instead. This is the last question, and it's another situation where we're talking about a mixture. This time it's about peanuts, apparently. And let's do this question and then say at least we have an idea how to solve percent and mixture problems. All right. Let's start with a 100 kilogram mixture of peanuts contains peanuts of two different kinds. So we have, well, one kind of peanut, we'll call that peanut 1, and another kind of peanut called peanut 2. I don't know what different kinds of peanuts there are out there, but apparently there's more than one. So one of the peanuts is priced at $2 per kilogram, the other's $2.40. If the mixture is priced at $2.08 per kilogram, how many kilograms of each kind of peanut does it contain? He or she wants a huge amount of peanuts, 100 kilograms. So if we take the first kind of peanuts and the second kind of peanuts, the total would be 100 kilograms. Okay? That's a lot of peanuts. Now, that's one line. We're going to have to come up with another line that has to do with the mixture. Okay? So let's look here. The first kind of peanut is $2 per kilogram. So it's $2 per kilogram of peanut 1. Okay? Plus, it's $2.40 per kilogram of peanut 2. Okay? Now this is talking about money. This second line here is talking about money. So the total amount of money would be how much? Well, be careful. Don't write $2.08 right here because we're talking about not per kilogram. We're talking about 100 kilograms of peanuts. So $2.08, if you multiply that by 100 kilograms, you will end up with $208. Okay, $208. So this one's talking about money, and this one here is talking about the weight of the peanuts. Okay? We have two lines though, and because we have two lines, we can now solve this thing using our technique for system of linear systems, or system of equations. What's the easiest way to deal with it? We could multiply this top line by, let's say, -2, just because that will make this cancel right here. As long as you multiply each one of these by the same number, you're fine. -2 times 100. -2 times 100 is what? Well, it's -200, right? And over here, this is going to cancel. So 240 minus 2 will leave us with 40 cents. That's the second type of peanut. And $208 minus 200 leaves us with $8. And divide both sides by 0.40 right here. Divide 8 divided by 0.40, and you should get 20, I believe. Okay, and because we have 20 kilograms of peanut number 2, and these two are supposed to equal 100, peanut 1 and peanut 2 are supposed to equal 100, we know that peanut number 1 should be 80. Okay, so 20 kilograms of peanut number 2, 80 kilograms of peanut number 1, and that is basically the answer they were looking for. We should put a sentence answer for this question, and if you really wanted to check and see if we got this right, you would put 2 times P1. I guess I could do that really quickly. 2 times P1 would be, well, 2 times 80 is 160. And if I took a calculator and I went, actually I don't even need a calculator for this, but 20 times 2.4, if you multiplied that out, that would be $48. And if you added these up, you would get 208, knowing that you should have got 208, and you would be happy because you know you got this answer right. So this is just an example of how to do mixture problems. Remember, there are many types of videos for these. There are money problems, there's distance time problems where you have a boat and you might have a current, or you might have a situation where you travel down the highway and you go a certain speed on one part and another speed on the second part. Those kinds of questions, they all have their own type of video for that, just to keep it from being way too long. Even this video probably, I'm guessing, is like 20 minutes. So yeah, it's a lot, but once you figure these things out, it's not so bad. In my opinion, these are definitely tricky, and I have students frustrated on these kinds of questions all the time. You are not alone if you too feel frustrated with these kinds of questions. They do take practice and a lot of perseverance. But just like all math, it's all doable with enough practice and perseverance. Anyway, I wish you a good day, and congratulations for listening to this point of the video. Wow, fantastic. Take care. Have a good day.